Hello, everyone, and welcome to today's webinar, DxConnect, Bridging the Gap to Zero Trust Security Amidst a Changing Network Landscape. Thank you to everyone for attending. My name is Lauren, and I will be your moderator today. Before we hear from Connor, I want to go over a few housekeeping items with you. All attendees will be muted throughout the entire presentation, but feel free to ask questions at any time using the Q&A pane on your screen. Connor will answer as many questions as time permits at the end of the presentation. So with all of that taken care of, let's get started. Here's your host for today, Connor Cox.
Thanks, Lauren. Thanks to everyone for joining today. So today, the topic of discussion is going to be a newly released technology called DxConnect that can help various organizations out there implement their zero trust architectures amidst some pretty significant changes in the networking landscape. So in terms of an agenda, first we're going to discuss what some of those changes are, and then talk through some of the problems that have arisen kind of as a result of those changes. And then finally, we'll get into the new approach to better meet those challenges. We'll walk through a demo of the solution and then leave some time for Q&A at the end. So one factor in this changing network landscape is the massive growth in the number of smart devices. So this is a bunch of data from Cisco, Intel, as well as the UN. And there's various predictions out there that are stating that there are going to be almost 30 billion smart devices within the next about 2.5 years now. So massive growth in smart devices, and machine-to-machine connections are becoming more and more prevalent as well. Additionally, there is this need for privileged access. So that need is actually growing faster than the world population is by a pretty significant amount, 7% versus 1%. So huge growth in that area. And then additionally, secure cloud-native microservice connections are going to become the fastest growing IP connection type by 2022 as well. So you've kind of got all these factors going on that are really changing the landscape in terms of networking. So let's take a look at some of the demands that are being placed on IT in terms of connectivity. So first of all, we've got those growing requirements, as we saw in that previous slide. Various users and organizations are requiring greater responsiveness when it comes to connecting to these various resources. And we've got several different approaches that currently need to be managed separately. And there are several issues as a result of these trends that you can see listed here on the slide. So, for example, we've got the legacy VPN, which carries a variety of limitations when you're looking to do hybrid cloud, multi-cloud, multi-site. This issue of privileged user access, this is oftentimes independent from various other systems, and they can be a challenge to manage as well. And then you've also got this need for cloud native access. So, scaling containers, various microservices, these cloud native apps are also adding to this issue here. And all of these demands can be really in conflict with one another. So a very classic approach to managing network security has been kind of the what we like to describe as the castle and moat VPN drawbridge approach. So essentially how this works is that any individuals or resources that are outside of the defined network perimeter is considered untrusted. So everything outside could be considered a threat, and anything inside that perimeter is considered trusted or secure. So essentially, this approach grants users network access to inside the perimeter via a VPN, via that drawbridge. So it has a major benefit of being able to very strongly fortify that perimeter. However, kind of nowadays, there are more and more factors that are causing this to be less effective. So the issue here is that because the network slice, essentially a segment of the network is opened up between the two resources from the external entity to the inside of the perimeter, it really opens up the organization to lateral network attacks. So basically what I mean by that is once an entity, a user is actually inside the perimeter, they could move around laterally and cause issues. So for example, if a user is connected via a VPN to the perimeter and they're supposed to have access to, let's say, a particular database and nothing else, a VPN approach makes it much easier for that user to gain access to other resources inside. So they can do things like move around and do reconnaissance within the perimeter and look for vulnerabilities and potentially cause issues. So really the castle and moat is great in theory, but if someone or something that is considered bad makes it inside, they can move around, oftentimes do so undetected. Then there's also the issue of tightening security through the VPN pipe. So that typically means managing things like access control lists, firewall policies, and that can carry some significant management overhead for many organizations. So you've got this wide open connection, and then you have to individually restrict access to various users and resources. And then the final point here is that in order to secure access to the cloud or between clouds, customers have to rely upon the cloud VPN or the VPN service. So this service can be a challenge to manage as well and can be very expensive. These cloud vendors can essentially charge an hourly fee for that VPN connection, and can be costly. And then the kind of the last component here with the cloud VPN is that it's not necessarily well built for microservices or those sort of cloud native solutions, things like containers. So with all of these sort of things going on, it's time to think about a new approach. So one that would help solve these challenges would also improve network security and meet some of these more common hybrid multi-cloud requirements, and would really improve performance and also support an open API for integrations. So this is really the goal of a connectivity solution that meets this set of changing factors in the networking landscape. So DH2I has developed an approach that really better maps to some of these new realities that we've discussed, and it overcomes the issues of the moat and castle VPNs. So this set of solutions is DxOdyssey and DxConnect, and I'll talk about how those sort of work together in just a moment, but it's basically a fully software-based technology that allows network administrators to create secure, encrypted application-level tunnels between users and applications, giving them essentially granular access to only those applications that they have been granted access to. So much more granular than kind of that wide VPN approach. And instead of removing access, you're simply adding access to those privileged entities. The best part of that from a security standpoint is that the resources on either side are completely invisible to the outside world. They're totally cloaked from any other sorts of entities to be able to see them. And so the way that that's accomplished is by not requiring any open ports. No VPNs are required or used. No direct links need to be in place. And so really, it's a solution that is more secure, less complex, and more highly performant than any other approach. So this type of an idea, type of concept is considered software-defined perimeter, because rather than having that more rigidly defined perimeter that's being fortified and connected to via VPN, the perimeter itself is very fluid and software defined. DH2I uses a very unique technology to actually transport the data. So it takes those TCP payloads and transports them via UDP. So essentially allows you to get sort of the best of both worlds there, in that it is both reliable and more highly performant. And so again, software-defined perimeter approach here. And what I wanted to do kind of at this stage is open up for a quick poll, just to see what you folks in the audience, what your experience is with a software-defined perimeter solution. So, have you looked into implementing something like an SDP solution yet? And so if you could just go ahead and answer the poll, that would be great. If you have, if you haven't, what your experience has been with that, we'd certainly appreciate the feedback. Great. So it looks like we're getting some responses. Some folks have done so only briefly, and some have not at all. So appreciate the feedback there. So let's dig a little bit deeper into the components of the solution. The first being DxOdyssey itself. So DxOdyssey is the gateway component of this software. And so what this essentially allows administrators to do, network administrators to do, is to create these tunnels either via a user interface or by using a command line or PowerShell, and can also interact with it via an API. But what this allows customers to do is, again, create these tunnels. These gateways can join with one another via what's called the DH2I matchmaking service, which I'll dig into a little bit further in just a moment. Grant that access. And by the way, this software is incredibly lightweight and can be installed on Windows or Linux machines. And so this gives you a lot of flexibility, right, in terms of how you size these machines. If you need to add more, it's all very simple to do so. But really, at minimum, you need 2 of these gateways to create what's called a gateway group. And you need to have at least one of them on the same site as the resources that you want to be able to connect to the destination for a particular tunnel. Okay, so that's DxOdyssey. Now, DxConnect is what kind of completes the story here, and this is what allows remote users to access DxOdyssey tunnels from anywhere. This uses the same encryption protocols for the various connections, but all this consists of is a username and password that can be defined by the gateway administrator, a very lightweight installation, a lightweight agent that runs on the remote devices, as well as a configuration file. And I'll show you how all of this works in a demo in just a second. But essentially, what's really great about this is that various users, as well as groups that they may be members of, can have their privileges to tunnels granted and revoked on the fly. Okay, so this can be added, removed as needed according to the requirements of the business. So let's look at a diagram that sort of outlines a remote user access type of use case. So essentially how this works is, first, the DxOdyssey gateway software would be installed on whichever machines you would like to act as gateways. So you can see here we've got 3 gateways in this group. One is on an on-premises location, one is in Azure, and the third one is in AWS. So again, at least one on each site. And then the gateway machines will join together with one another by registering with the DH2I Cloud Matchmaking Service. So this is a very lightweight process by which these gateways will register with the matchmaker, and then at that point they will then communicate with one another directly. Okay, so it's not a situation where these gateways will need to check with the matchmaker every time they want to talk to each other. It's just for that initial meeting, right? That's why we call it a matchmaking service, and then they can communicate directly with one another. At that point, the gateway administrators can then create as many tunnels as they wish between the gateways. Okay, so in this example, we have a tunnel going to a particular application in Azure, another one in AWS. Okay, so super easy to set up. If you have any local users where this gateway resides, on the origin site, then they don't have to install anything additional. All they have to do is connect to that origin gateway, and that traffic is then forwarded on to whatever the destination is. Okay, so what's really great about that is that that site is completely isolated from the destination. There's no VPN in the mix here whatsoever. And that user simply connects locally to that origin gateway. So it doesn't have to actually connect to any remote service. It just connects locally, and the tunnel forwards that on to the destination. Then for the remote user, wherever they happen to be, all they need to do is install DxConnect on their remote machine, and they can access those tunnels as well based on the configuration that the the gateway administrator has put in place. Okay, again, no VPNs, no direct links. These resources, these applications are completely invisible, yet the users locally or remote can access them very simply. And when I say applications, this could be really any application, any TCP app. So, think of something like a database system, something of that nature. Also, let's say you just have a user that needs access to a particular machine. If I need RDP access, for example, I can very simply set that up and grant this user RDP access to these servers that are running in various different clouds. So here's an additional use case. Here we have an application that consists of various microservices, and they're running in disparate networks. Okay, so this one might be in AWS, the other one, let's say, is in Azure. And so all of these various different microservices need to communicate with one another. And so essentially, by adding DxOdyssey on the side of each of those microservices, they can communicate with one another directly. This is very interesting for folks that are doing DevOps. So these microservices can communicate very easily and securely. And then the remote DevOps user who may be managing this from somewhere else can very easily gain access to their applications, okay, those various services, and access them from wherever they happen to be. Again, no VPNs required, and all of these microservices can be running in completely separate networks. So a final use case here, this is an Internet of Things device, IoT use case. So essentially what this allows for is that these edge devices can connect securely to either one another, to some remote server application backend, let's say, and then also the remote user can access these resources as well in this application on the backend. So, as this explosion devices occurs, which we saw towards the beginning of the presentation, this is a very simple way to tie them together securely and simply without having to configure specialized hardware, VPNs, those types of solutions. So what I want to do now is go through a live demo to sort of illustrate this solution. So what we're going to do is take a look at a gateway group, a set of gateways that we have already joined together. One in an office in one of our offices in Fort Collins, Colorado, and the other in Azure, running in Azure. So we've already created that group, but I'll just give you a quick tour of those two. And then what we're going to do is create a tunnel from on-premises to a database running in Azure that's in the same network as this Win1 gateway. Okay, so we're going to create that tunnel, and then what we're going to do is connect to that database instance and show those two different use cases. One, the local user that also is just sitting in that DH2I office. So Lab 4 is going to connect to Lab 5 and then access that workload. And then finally, we'll show connecting via DxConnect on this remote user that could be anywhere. Okay, so let's go ahead and jump over to this Win1 machine, which is our gateway in Azure. So I'll just click on that. And you can see that we've joined together these two gateways into what we call a gateway group. So Lab 5, this is the one on premises in the Fort Collins data center, and Win1 is the machine that resides in Azure. Yeah, so we've joined them together. They register via the gateway group. The only requirement that we have for these machines is that they have access to the public internet. So that's how they're communicating with one another. And you might be wondering, well, you know, what's my latency going to be like between these sites? Well, that's all up to whatever your ISP is going to provide. Okay, so whatever you want to pay for from your ISP, that's going to impact your tunnel speed. But essentially, we've got our two gateway group. And so let's go to the tunnel manager now. So from the tunnel manager, I can see all the tunnels that I've created. You can see I've already set up a couple of different tunnels here. But what we're going to do is just add a new tunnel. Okay, so we're just going to give it a logical name here. And then this section is all about the destination of this particular tunnel. Since we're trying to get to our Azure environment, destination gateway is going to be the Win1 machine. And then the target host, if you'll remember, is going to be this SQL server. Okay, so I'll just go ahead and enter the name of that host. And then the port number, in this case, it's going to be 1433. That is the port on which that particular database workload is running. And then we're going to add some information for the origin. So our Lab 5 gateway will be the origin. We want to allow all on this particular machine and then set a port on that Lab 5 machine on that origin gateway for connections to this tunnel. Okay, so we're going to set that on 30433. And then we can add any filters that we want here. We don't have any filters that we've configured, but we can filter particular IPs. Just think of it as IP filtering if we only want to allow certain clients or certain machines within the Fort Collins office to access this tunnel. But right now we'll just allow all. Click OK. And the tunnel's created. Okay, so very minimal time to actually set up these tunnels. And as I said before, you can do all of this from the CLI. You can script it via PowerShell. It's completely up to you in terms of how you set this up, but this is how you do it through the UI. So the tunnel has been created. Now what we want to do is go out to this Lab 4 machine and see if we can't connect to Lab 5 on that tunnel port. Okay, so if we look at this tunnel here, we're going to need to go to Lab 5 on 30433. So let's go to Lab 4 and connect So lab 5, okay, so this is a SQL Server instance, so we're pulling up SSMS for just for an example here. Lab 5 on 30433. Of course, we need to authenticate to this instance. So I'll enter the password there. And as you can see, we are now connected to our SQL Server instance that's running in Azure. Okay, and we can do a quick query here just to sort of demonstrate that. We'll just say do the server name. Just take a look at the version of SQL Server that we happen to be running, and then the host name. Oops. And we'll execute that. Okay, so you can tell that the server that we're connecting to is actually the Red Hat server that's running the SQL Server instance. It's running SQL Server 2017, and then we're connecting from Lab 4. Right, so pretty cool. There's no VPN here. There's no direct link. We are connecting to a resource that's running in the cloud without ever leaving our local network. So let's go back to the management of our gateways, our tunnels. And now we want to allow our remote user to access this same tunnel. So how do we do that? So let's go to our client and group manager and add a new client. So we'll go ahead and add this client here, user 1, set some password for them, and then submit that. Okay, so here's our user. We also need to export a configuration file for this user to use. So we'll just save that to the desktop. Call it connect.config, and we'll replace the one that's already there. So we save that to the desktop. We set up this user, and then the final thing we need to do is ensure that this user is granted access to this tunnel. So let's go back to the tunnel. We'll select the tunnel that we're interested in. We'll manage the clients that are associated with it. So we want to add a client. Yes, we want to add user 1. And then we're going to set the listening port for this user to connect to the same instance. And we'll just use the same one, 30433. And we'll add, okay, and then submit that. All right, so you can see they've been added. And of course, I can always remove clients as needed. So I can add, remove very simply. And then also under the client side, I can add what are called groups. So I can like add a new group if I want to, say I just want to allow all my devs access to this or all my DBAs access to this. I can very easily do that and add permissions for a group. We're just going to do a user for now. And then, so essentially what we need to do now is go out to that client machine and install. Okay, so we have the installation package here. We've got the configuration file sitting on this machine. And then obviously we'll need to provide the username and password to this person. But once that's all done, we can install DxConnect. So that's just going to prompt us a couple times, and now that's been completed. Okay, so we'll go ahead and run DxConnect. Enter our path for our configuration file, which in this case is on the desktop there. And then enter our username and password. So user 1, enter that password we just set up, and hit connect. Okay, so we're connected now. If we want to see the status of our connections, we have a little icon that runs in the tray here for DxConnect, and we can take a look at the status. So here we can see any tunnels that we have been granted access to, as well as where that listener is running. So currently, local loopback on 30433. So let's go ahead and connect to that instance from this machine. Local loopback 30433 for our connection string. So I need to authenticate again to the instance, hit connect, and we're connected again. Okay, essentially connected to that same instance, but from a remote machine. Maybe it's at a coffee shop or working from home, whatever it happens to be. Okay. Again, no VPNs, no direct links. All of the external ports are closed for that SQL Server instance, but we can still get to it securely via this tool. Now, let's say we didn't want this individual to have access to this tunnel anymore. Let's just go back to Tunnel Manager, manage the clients, remove this user from the tunnel, hit submit. Okay, so they're going to be removed. As you can see, they're not listed under the clients anymore. Go back to our machine here, try and refresh this connection. And that's going to fail, right? That's what we would expect. And you can see here that this user no longer has that tunnel listed under their status. Okay, so we're getting a pinwheel there. As I mentioned before, this is also very useful for things like remote access. So let's say I wanted to set up a tunnel for folks to RDP to my Win1 machine. So I would just set up a tunnel like this. Go ahead and add my client. Let's see here, actually. Let's see, 33389, so we'll just add that client on some port, submit that. Again, it's all real time. So if I go back out to my user, we're seeing that SQL Server error as expected. If I pull up Connect, look at the status. Oops. Okay, I can see I now have that RDP at 33389. So if I just pull up RDP here, local loopback, (33389), create a session. Okay, now we have a remote access, an RDP session to that particular machine that we were just on. And of course, we've been kicked out of our other session here because of that user. Okay, so SSH, RDP, any application really that you want to be able to create tunnels for, super easy to do so, whether you're doing it via this UI or scripting things out. Back to slides here. So before we get into questions, what I want to do is just open up another poll about kind of what you've seen today. And so I can just navigate to this. Just want to understand if, the folks in the room, if you're interested in kind of learning a little bit more about DxOdyssey and DxConnect, would you like some more information about this? Would you like to try this out for yourself? Yeah, you're looking for some more information, but not quite at this time, or the last option would be no. So you can just take a second to take to go ahead and vote on that. The other thing that I'll mention here is that we do have trials of this software. The trials are free. They run for about 30 days, and they allow you to install this on your own stack, on your own hardware, and to just try things out and create a couple tunnels and just see what you think. So, you know, certainly if that's of interest to you, get in touch. Let me go ahead and close that poll. The other piece here is if you were interested in the demo, you know, you want to see a little bit more, you'd like a personalized demo, there's a link there where you can get access to a demo, and we can have kind of a one-on-one session with you and your team. So with that, looks like we've got some questions coming in, so I will hand it back over to Lauren to go ahead and moderate the Q&A.
Thank you, Connor. So let's get into some of these questions. Feel free to keep typing in those questions into the Q&A pane at any time, and we will get through as many as we can. So the first question it looks like is, does it support IPv6?
Yes, it does. So the examples you saw today, obviously were all IPv4, but yeah, we support IPv6 as well.
Awesome. Someone asked, if we have a direct link between our sites to the public cloud deployments today, would they still need something like this?
That's a great question. So if you've got a direct link, you can certainly use this to layer on top of that infrastructure to provide a little bit more granular tunnels than just having things wide open and having to set up the various rules to restrict access. You can absolutely add this to add more robust security between your sites or between your clouds.
Awesome, thank you. Is there a contract term, or do they pay for usage?
Yeah, so DxOdyssey and Connect, the licensing is pretty simple. It's a 1-year term, kind of a subscription type model. And there's a couple different ways you can do it. One, you can just license DxOdyssey and run as many clients as you want. And then the other option would be to license DxOdyssey and then license for each one of your users. So if you got a couple users, that's typically the way to go. If you have a lot of users, then just license those Odyssey gateways and run unlimited users.
Okay, and how are you administering the gateways/routers?
Good question. So, you know, the gateways themselves, they're just machines. So physical machines, virtual machines, Windows, Linux, it's all pretty up to you because it's software based. And I'm administering them via the UI, which you saw in the demo, but also, you know, you can do things via CLI and scripting and things of that nature and interact with it via the API. So you have a variety of options there. We also have a client version of the admin console, that UI that you saw. So you can actually administer your gateways remotely through the UI as well.
Cool, thank you. The next question I see here is, does it still work if my gateways have no access to the internet?
No. So your gateways are going to need to have access to the internet in order to communicate with one another and to register with the matchmaking service. So that will be a requirement. They'll need to be able to get out to the internet.
Okay, the next question I see here is, do clients need to install something on their machines to access these tunnels?
Well, it depends. If your clients are on premises where one of your gateways resides, they do not need to install anything. As you saw with that Lab 4 machine, we're just simply going out and hitting that Lab 5 machine. So if you've got network connectivity between your users and one of your gateways, you don't necessarily need to install anything. However, for that remote user use case, you're going to need to install that DxConnect agent on those machines.
Okay, and this question, what are the installation prerequisites for a DxOdyssey gateway?
That's a great question. So for Windows, you're going to need to have .NET 4.5 in order to run the software. And then on Linux, you're going to need .NET Core 2.1 in order to install on a Linux box. For Linux, the flavors of Linux we support are going to be Red Hat and Red Hat derivatives, so CentOS we've got full support for, and then you can run the gateway software on Ubuntu as well.
All right, this next question, what's the difference between DxO and DxC and any other SDP vendors out there?
That is a great question. So there are a variety of other vendors that are innovating in the SDP space. And actually, I think it would be helpful to kind of pull up a visual to see how we compare. So if you'll just give me a moment here, I have a comparison chart to pull up. So just bear with me while I pull that up. All right, and so hopefully you can see my screen. So just kind of run through these one by one. Number one is the data transmission protocol. So we are using UDP, whereas most solutions will leverage just TCP in and of itself. So we've got that level of higher performance and also high reliability because we have implemented some of the RFCs from TCP, such as selective or such as retransmit and acknowledgements and those sorts of things. DxOdyssey does not have what's considered a controller node, and so many other SDP solutions require such a controller, and that can become a bottleneck and actually open up for additional security issues as well. DH2I, our SDP solution, can actually create truly highly available gateways. So if you set up a couple gateways next to each other, if one goes down, that connection will fail over and be uninterrupted through other gateways. And there's some kind of rudimentary HA available with other SDP solutions, but they're not as robust as ours. And DNS also kind of factors into that. So we don't actually require DNS for our gateways, whereas many others do. We can integrate very easily with our open API for your various applications that may need this, whereas others have more limited integrations. And then the final one here is that, DH2I, our solution doesn't strictly adhere to the Cloud Security Alliance SDP specification, whereas most of the others do. That being said, many of us here at DH2I are members of the CSA Software Defined Perimeter Working Group. However, we do not adhere as strictly to that specification because we think that our own proprietary approach is actually superior to that specification itself. So, so those are kind of some of the main ones. There are certainly a variety of other vendors out there, so check them out. But we think we have a superior solution for these reasons.
All right, and I think we can squeeze in one more question here before time runs out. Let's see. How would you generally size the gateway machines? I know you can scale up or out, but they're not sure where to start.
Yeah, that's a good question. So, really just, you can start small. So really any servers of any particular class would work just fine. Start with a couple gigs of RAM, maybe 3.5 gigs of RAM. That should be, plenty of performance for you to get started, and, would obviously start you off with really more horsepower than any VPN router out there anyways. So yeah, start with a, few gigs of RAM and kind of go from there.
Okay, thank you to everyone for joining us. That is all the time we have for today. If you have any additional questions, feel free to reach out to us. If we didn't get to your question, we will reach out to you personally to answer that question. We'll also be following up with all of you shortly with the recording of this webinar. Thank you again for your participation, and we hope to see you at our other upcoming webinars.
Thanks.